All right, this is section 11.5, review of factoring techniques. So I'm going to walk through the various steps here, and then we will move right into examples. So step one, you should always factor out the greatest common factor, or the GCF, if that's possible. Always, always look for the GCF. Once you've done that, if you can take out a GCF, you're usually not done. You need to go ahead and move on to step two. Something that's important to remember is there are times when you're looking for that common monomial factor, the only thing you can take out is a -1. If your leading coefficient is negative, that's often what you're going to factor out. So that's your first step. Always, always, always look for the GCF. Then the second step is trying to determine how many terms your polynomial has so you can determine what your method is going to be. So you'll notice on here I've got different notes. Anytime you see in parentheses C formula sheet, that means it's a formula you do not have to memorize. You're going to be able to find it on that formula sheet that you will be able to use when we are taking our module exams. So hope I just see. I'm hoping to annotate here. So the first type you should be looking for is a binomial. So that has two terms. And there are four types of binomials. You have a difference of squares, which is factorable. It's on your formula sheet. You have a sum of squares. That is not factorable. You have a sum of cubes, which is factorable, also on your formula sheet. And you have a difference of cubes, which is factorable and on your formula sheet. If it doesn't have two terms, it's likely going to have three terms, which we call a trinomial. And there is perfect square trinomials, which you will find that formula on your formula sheet, and that is factorable. The one thing I will mention about a perfect square trinomial is that it can be factored like any other trinomial. So if you don't recognize right away that you have a perfect square trinomial, that's fine. You can just factor it with one of these other two methods here. If we go back up to the top and we look at the binomials, the difference of squares, sum of cubes, difference of cubes, those are formulas you're just going to have to be able to plug numbers into to be able to factor those. Those are not things that have a really easy method for factoring. So there's really two things you can do when you have a trinomial. You can do trial and error, or what I called guess and check when I was in school. And that's really just plugging things in and seeing what works. So you're going to plug things in to your parentheses, and you're going to check your answer, which is really step 3, and see which one gets you back to your original. The guidelines that are here with trial and error are important to remember no matter how you are choosing to factor your trinomial. If the sign of your constant term, which is your last term, is positive, then the signs of both of your factors are going to be the same. So they'll either both be positive or they will both be negative. If the sign of the constant term is negative, or your last term is negative, then the signs in your factors are going to be different. One's going to be positive and one's going to be negative. So if we go back and we look at the 2a, when we talk about the constant term is positive, if your middle term is negative, both of your signs are going to be negative. If your middle term is positive, both of your signs are going to be positive. For 2b, if your constant term is negative, you're going to have one positive factor and one negative factor. The larger factor needs to match the sign of your middle term. Okay, the larger factor needs to match the sign of your bigger term. The majority of you probably learned to factor using the AC method. So that's where you multiplied A times C, or the coefficient of your leading term, times your constant term. Then you looked for two factors that multiplied to give you that number and added to give you your middle term, or B. If you can't find that right combination, then it isn't factorable. Once you've determined what your two factors are, you're going to rewrite your trinomial as a polynomial with 4 terms. So you're going to replace that bx, that middle term, with 2 different terms. And then you're going to factor by grouping. And then finally, you did encounter some polynomials that had 4 terms, and whenever there's 4 terms, you always try to factor by grouping. The third step when you're factoring, it should always be to check your answers. It's really easy to make sign mistakes. I think that's probably the biggest mistake people make when they're factoring. So checking your answer usually catches that sign mistake. So I know it's an extra step, but I think it's a really important step. So in MA 128, we're going to do a lot of factoring. So I'm not going to teach you factoring, but we will review it really quickly. I've got 15 examples to go through with you. And so that's what I'm going to do for you. We're not going to really cover in detail all of these different methods for factoring. So just keep that in mind. I am going to go ahead and write the formulas in here. When I do that, the text is going to go back. It's not going to be where it is indented like that. So sorry about that. Still working on trying to figure out how to make that work in here. So I'm going to go ahead and show you what the formulas are for each of these that we talked about, just so you see them. So a difference of squares is going to look like a squared minus b squared. So both terms are going to be perfect squares, and then that factors into a plus b times a minus b. All right. Remember, sum of squares isn't factorable. Sum of cubes looks like a cubed plus b cubed. So both of those are perfect cubes. And this factors into a plus b times a squared minus ab plus b squared. And for a difference of cubes, you have a cubed minus b cubed, which factors into a minus b times a squared plus ab plus b squared. All right, so in all of these situations, what you really need to do is you need to identify a and identify b. And then you are plugging things into your formulas. The perfect square trinomials, I'm really not going to focus on those and put those formulas in there because, again, to me, the best thing to do here is factor these like any other trinomial. I think that's much easier than trying to figure out if it is really a perfect square trinomial. The formula is there if you want to play with it and learn it, that's fine, but I really, really think when it's a trinomial, your best bet is going with the AC method. All right, so let's start our examples. So here we have example number 1. So the first thing you're asking yourself, how many terms? That's important, how many terms? So 2 terms, which means binomial. So remember, we have difference of squares, sum of squares, difference of cubes, sum of cubes. All right, so this one happens to be, so 1 is a perfect square. 4x squared is a perfect square. But this is a sum of perfect squares, which means it's not factorable. So when you're working in HOX, there's a little button next to this one, so you would just click in the little button beside not factorable. All right, sum of squares does not work. All right, so here's our second example. Completely factor the given polynomial if possible. If the polynomial cannot be factored, indicate not factorable. So we need to look for a GCF. I'm looking at this problem and all of these numbers are prime, so there's no greatest common factor. All right, so it's a trinomial. So how many terms? We have 3, so we have a trinomial. All right. And so this is where the A's, the B's, and the C's come in. So we're going to use the AC method. So we're going to take A times C first. So in this case, that's 2 times 1. And I'm going to do a little T-chart over here to help keep me organized. Not a very good vertical line there. So 2 times 1. So I'm going to look for two things that when I multiply them together give me 2. And when I add them together, give me 3. So this one is not overly hard because I only have one set of factors. So 2 times 1 does give me 2, and 2 plus 1 does give me 3. So I'm going to take these two factors, which are 2 and 1, and I'm going to come over here, and I'm going to replace this middle term with those two factors. So plus 2v plus v plus 1. So here I've replaced that middle term with these two factors here. All right, and now I'm going to factor by grouping. So I'm going to look at the first two, and I'm going to look at the last two, and I'm going to take a greatest common factor out of each one. So when I look at the first two, they both have a 2 in common, and they both have a v in common. So that's my greatest common factor, is 2v. And what I'm left with is v plus 1. So if you're trying to follow along here, 2v times v gets me back to v squared. 2v times 1 gets me back to 2v. All right. Over here, the only common factor they have is a 1, but I'm going to go ahead and take it out. All right. Now notice that what we have here is another common factor. So that's what we call our binomial common factor. So we're going to factor that out, v plus 1. And then my other parentheses is going to have what's left, which is 2v plus 1. And I'm not sure why I wrote 11. Now let's check this. It's always a good idea to check. I know it's an extra step, but check it anyway. So to check it, I'm going to multiply what I have there together and see if I get back to my original. So v times 2v is 2v squared. V times 1 is v. 1 times 2v is 2v. 1 times 1 is 1. Collect those like terms. I have 2v squared plus 3v plus 1. So it checks. So I'll come back over here, and I'll go ahead and box or circle my answer. All right, here's our third example. X squared plus 11x plus 24. So leading coefficient is 1, so I don't have a GCF to worry about. I have that trinomial again, so I'm going to use that AC method. So 1, there's a 1 here. So 1 times 24 is 24. So I'm looking for two factors of 24 that add to give me 11. So 1 times 24, 2 times 12, 3 times 8, 4 times 6. I think that's it. So now I'll add those together. This one gives me 25. That one gives me 14. That gives me 11. This one gives me 10. So this is the one I want because it adds to 11. So now I'm going to go in there and I'm going to replace that middle term with these two factors here, 8 and 3. So x squared plus 8x plus 3x plus 24. And then I'm going to factor by grouping. So I'm going to look at the first two and the last two. What's the GCF for the first two? It's just an x, it looks like, which leaves me with x plus 8. The GCF on the second pair looks like a 3, which leaves me x plus 8. That's what I want. It's always important that what's left in each of these parentheses is the same, because that's our common binomial factor. So I will factor out the x plus 8, and the other parentheses is going to have what's left, which is x plus 3. Now we're going to go in here and we're going to check this. So we're going to take x plus 8 times x plus 3. See what we get. X squared plus 3x plus 8x plus 24. Those two are like terms, so x squared plus 11x plus 24, that checks. So we'll come back here and box in our answer, which you would be typing into Hawks. All right, so let's move to the next example. All right, so GCF, I don't think so because I've got just a coefficient of 1 here, but I do notice something here. Look at this. We have how many terms? 1, 2, 3, 4. So this one has 4 terms. So that means we're going to factor by grouping, which essentially eliminates, you factor by grouping when you do the AC method once you figure out what those two factors are in the middle, once you rewrite it as a polynomial with 4 terms. So we just get to skip that step. So the easiest thing is just to look at the first 2 and the last 2 and see if you can find common factors in those. So if I look at the first 2, it looks like they have a y in common. So I'm going to factor out the y, which is going to leave me with x plus 7. When I look at the second 2, since this is a minus sign, I'm going to factor out a negative number. And it looks like 2 and 14 are both even, so I'm going to factor out a negative 2, which is going to leave me with x plus 7. So that makes me happy. Because look, x plus 7, x plus 7. All right, and then what's in my left is y minus 2. So let's check this and see if it worked. So we're going to take x plus 7 times y minus 2. So xy minus 2x plus 7y minus 14. I can't put any like terms together, but I think it works. It's a little bit different order. Here's an xy, here's an xy. I've got a plus 7y and a plus 7y. I have a negative 2x and a negative 2x, and I have a negative 14. So those middle terms switched around, but that's okay. As long as the signs stayed with them, we're good. So we're going to come over here and box in our answer. All right, let's move on to the next example. Now this one, I'm looking at it and I'm thinking, okay, 2x squared, 20x, 32. They're all even numbers, so I bet I have a greatest common factor in this case. And that greatest common factor is going to be 2. So we're going to take out our 2 at the very beginning. So our GCF is 2. So factor that out first. That leaves me with x squared plus 10x plus 16. All right, now I may be done and I may not be done, but I can't stop here. Okay, you've got to look at here at this trinomial and see if it's factorable. So we're going to do the AC method. So we're going to see if we can find 2 factors of 16 that add to give us 10. So 1 times 16, 2 times 8, no 3s, but 4 times 4. So this gives me 17, this gives me 10, this gives me 8. So remember, I'm trying to match my middle term. And I think I found one. It's that combination right there in the middle. So The magic one is right here. That gives me my middle term. So these are the factors I'm going to use to replace the middle term. Very important, don't lose that 2. All right, keep that out there. Rewriting that trinomial to a polynomial with 4 terms, x squared plus 2x plus 8x plus 16. Come in here, look at those first 2 and last 2, first 2 and last 2. Okay, keep that 2 out there. Factor out x between the first 2, which leaves me with x plus 2. Looks like I can factor out an 8, which leaves me with x plus 2. There's our common factor. Keep that 2 out there. X plus 2. The other parentheses is going to have the x plus 8. All right, and if you wanted to, you can check this. I highly recommend it. But there we have our answer. And I know I'm moving through these kind of quickly, but it is recorded and you can go back and rewatch it as many times as you need to do that. All right. All right, so here's our next one. This is example number 6. Again, just factoring here. It's a trinomial. I have an 8, 2, and a 3. They have no GCF. So I'm just going to go with the AC method. Take 8 times -3. This is the first one we've had that's had a negative there. Okay, so 2 factors of -24 that when I add them together become a -2. So if you remember when we were on that first page, I said that if your signs are going to be opposite, and that's what happens when you have a negative for your constant term, then the larger factor has to have the sign of your middle term. So when I'm listing my factors, the larger factor is going to always be negative. So 1 times -24, 2 times -12, 3 times -8, 4 times -6. All right, so then when I add these things together, this one gives me a -23, this one gives me -10, this one gives me -5, this one gives me -2. So there's our combination right there, -2. So we're going to replace that middle term with +4 and -6. So 8c squared plus 4c minus 6c minus 3. Remember, we keep our first, keep our last. You replace the middle. So now we look at those first 2 and last 2. Greatest common factor between the first 2 is a 4c, which leaves me with 2c plus 1. Greatest common factor in those last 2 is a -3, which leaves me 2c plus 1. There's our common factor binomial, and I'm left with 4c minus 3. And that's my solution. So here's our next one. 12n squared minus 60n plus 90. So I'm thinking at least 3 goes into all of those. Maybe 6. I know 6 will go into 12. I know 6 goes into 60. Does 6 go into 90? Let's just do a little math over here on the side and see. If you have a calculator, of course, you can pull that out. It does 15 times. All right, so our greatest common factor then, this is our GCF is 6. So let's factor that out, 6. So 6 times 2n squared minus 10n plus 15. It's not a very good 5. Let's see if we can fix that. All right, not quite done. We need to make sure that we don't have a trinomial here that's factorable. So we're going to do the AC method. So 2 times 15. I'm going to look for two factors of 30 that when I add them together give me a negative 10. So they're both going to have to be negative here. No, negative 1 times negative 30, negative 2 times negative 15, negative 3 times negative 10. 4 doesn't go into it. 5, so negative 5 times negative 6. This gives me negative 31, negative 17, negative 13, negative 11. So none of those are adding up to be 10. So I'm done. This is it. So it's not factorable here as a trinomial, but I did factor it. So if you take out a GCF, this is very important. Very important. Let me find a different color. There we go. If you take out a GCF, you factored. So you go back over here, and this is the answer that you're going to type into HOX. All right? Because it did factor. The trinomial inside didn't factor, but you took out a greatest common factor. So remember, when you're factoring things, you're writing it as a product of two things. And this is 6 times 2n squared minus 10n plus 15. Okay, here's example number 8. So we're back to a binomial. We haven't seen that for a while. So still look for GCF, which I think there is one actually. It looks like 3. We'll go into those. So let's take out a 3. 3 times 9x squared minus y squared. All right, just like before, we still have to look at what's inside and see if it's factorable. So I'm thinking it is. I've got a minus sign, so I know minus signs usually work, either a difference of squares or a difference of cubes. So I just have to determine if these are perfect squares, and I think they are. 9 is a perfect square, x squared is a perfect square, so is y squared. So remember, difference of squares looks like this. And these parentheses can be rewritten, a plus b, a minus b, a minus b, a plus b. It doesn't really matter. So I just have to identify what do I take times itself here to get 9x squared. So I keep my 3 on the outside. So essentially in this problem, my a is 3x and my b is y. So that's going to be 3x plus y, 3x minus y. Okay. So box that one in. That's our answer. All right, example number 9. We're back to a trinomial. All right, 20, 125, 30. So popping into my head is a GCF of 5. I think 5, I know 5 will go into all of them. I don't know that there's one that's bigger than 5. So let's go ahead and take out the 5. That leaves us with 4x squared plus 25x plus 6. Okay. So now I need to look at that trinomial. We're going to take a times c. So 4 times 6 is 24. So I'm looking for two factors of 24 that when I add them together give me 25. So 1 times 24, I think I got it right there. That's the one. That was, didn't have to work very hard for this one, did I? All right, so keep that 5 out there. 4x squared. I'm going to go ahead and put the 24x first, plus x plus 6. It really doesn't matter, but sometimes it just, I like to know that my first one's definitely got something in common. All right, keep the 5. 4x is my greatest common factor for those first two. It leaves me with x plus 6. The only thing x and 6 have in common is a 1, but that's okay. I can take out the 1. All right, and now here's our binomial that's in common. So keep that 5, x plus 6. Here's what's left, 4x plus 1. That's your solution. Hopefully this is clicking for all of you, because if you've gotten this far, you should be master factors. All right, here we have another one, example number 10. So 2x squared plus 4x minus 30. Those are all even numbers, so I know my GCF of 2 is going to work. So I'm going to take out the 2. It leaves me with x squared plus 2x minus 15. Okay, so next we're going to do that AC method. So we've got 1 times negative 15, so 2 factors of negative 15 that when I add them together give me 2. So here again, negative means opposite signs. Sign of the larger factor needs to be positive because my middle term is positive. So this will be 15 times negative 1, 3, and actually it would be negative 3 times positive 5. Those are all of our factors. So when I add this together, I get 14, and here I get 2. So here's our combo right there. So rewrite the trinomial inside of there. X squared minus 3x plus 5x minus 15. Look at each pair separately. Keep that 2. I can factor out an x, which leaves me with x minus 3 with those first 2. 5x and a 15. I'm going to factor out a 5, which leaves me with x minus 3. I'm liking what I'm seeing. There's our binomial that we have in common. Keep the 2. Factor out that binomial. And the other binomial is what was left, x plus 5. Put a box around that. Actually, what you're doing on yours end is typing that into Hawks. Oops, got my box a little crazy. All right, here we go. Completely factor if possible again. Now this one has 4 terms, so I'm going to factor by grouping. Don't have to worry about multiplying and finding the 2 factors here. You still have to worry about GCF, so you need to take a look at it. The first 3 are even, but the last one's not. The first 3 have D's, the last one doesn't, so no GCF here. So we're going to go straight into just looking at first 2 and last 2, trying to find that greatest common factor. So I know D squared, and it looks like 2 because they're both even. So that's going to leave me with 8D plus 7. On the second set of parentheses there, the only thing they have in common is a negative 1, which is going to leave me with 8D plus 7. So again, very nice. Got those 2 there. So that's my binomial common factor. Got my 8 a little carried away. Trying to get to the eraser here. There we go. Straighten that 8 up. So we have 8D plus 7. And the other parentheses is going to have 2D squared minus 1. All right, so something I will mention here is you need to be a little careful when you've factored out and you have something that is like this 2D squared minus 1. Sometimes you have a difference of square here. Not always, but sometimes you do. And in this case, I don't because 2 isn't a perfect square. But occasionally they'll throw one of those in there for you, so just be a little bit careful. All right, and we can box this in, or you're going to type that into Hawks. And all of these problems came straight out of practice in Hawks. I just rewrote them in Zoom so I could go through them with you. Okay, so here we go again. factoring if factorable, binomial, so minus sign, that's good. Looking to see if we have a difference of squares, because I have a y squared and an x squared. So y times y, x times x, 2 times 2. So I have a difference of squares. So my a is y, and my b is 2x. So remember the formula, a squared minus b squared is equal to a plus b times a minus b. So for this problem, that's y plus 2x, y minus 2x. And you box that one in. Okay, just 3 more examples. So trinomial, 1, 2, 3 terms. Doesn't look like they have a common factor because 2 is even, 15 is odd, so, and 2 is prime. So I'm going to just go with the AC method here. So 2 times 18 is 36. And 2 factors of 36 that when I add them together give me 15. So 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. That adds to 37. That one adds to 20. This one adds to 15. Oh, there's our combination right there. We don't have to keep going. Notice when I go through that, I start at the lowest and keep going. I think it's, you don't miss factors that way. If you start, just start with the smallest factor that goes into it. So just may seem like it takes more time, but if you do that, you're not going to have a chance of missing something. So we're going to rewrite this. 2x squared plus 3x plus 12x plus 18. Greatest common factor between 2x squared and 3x is just going to be x, which leaves me with 2x plus 3. Greatest common factor between 12x and 18 is going to be 6, which leaves me with 2x plus 3. So there's our binomial, 2x plus 3, and we're left with x plus 6. All right. Here is example 14. I like it when the leading coefficient is 1. That usually makes it a little bit easier because I've got a trinomial. I'm taking a times c, which just basically means c here. So 2 factors of negative 12 that when I add them together give me a negative 4. So the larger factor is going to be negative 1 times negative 12, 2 times negative 6, 3 times negative 4, and I think that's it. So there we have negative 11, there we have negative 4, there we have negative 1. So here's our combination. Rewriting it, x squared plus 2x minus 6x minus 12. Keeping the first and last, replacing the middle. Greatest common factor in the first one, excuse me, I did my parentheses too soon. Greatest common factor between the first two is an x, which leaves me with x plus 2. Greatest common factor between the second two is a negative 6, which leaves me with x plus 2. So there's our binomial, x plus 2. And my other parentheses is going to have what's left, which is x minus 6. So that's what you're typing into Hawks right there, and I'm going to box it. All right, final example. Okay, now this one looks like a binomial. I see a cube there, which I'm thinking, ooh, maybe difference of cubes. But remember, greatest common factor always. Always, always, always. So both of those numbers are even, so I know they at least have a number that's in common. So, and I think probably more than just 2. So I think 64 and 100 are both divisible by 4. So our GCF is a 4, but they also have x cubed x. So they also have an x in common. So I'm going to take out my GCF, which is 4x. And that leaves me with 4 times 16x squared minus 25. Okay? Because 4 times 16 is 64, 4 times 25 is 100. All right, now 16x squared is a perfect square. 25 is a perfect square. So that's going to factor. Keep the 4x. And then another 4x in here. I'm going to have 4x plus 5 and 4x minus 5. All right. I'm going to give you one problem to try. And I'll give you some time to do it. I'm just going to write this one out. So this is a U-try problem. So this one is going to be xy plus 7y minus 7x minus 49. I'm going to give you some time here to work on this one. And then we'll come back and look at the answer. I'm going to give you about another minute. All right, let's go through this one. Let's see how you did. Hopefully you've worked it. So 4 terms. So we're going to look at the first 2 and the last 2 and try to find a greatest common factor. So the greatest common factor between xy and 7y is a y. And I'm left with x plus 7. Greatest common factor between negative 7x and negative 49 looks like a negative 7, which leaves me with x plus 7. There's my binomial term, x plus 7. And my other binomial is what's left, which is y minus 7. All right, so that's our review of factoring. We will spend a lot of time factoring. So MA 128 is all about factoring and rational expressions, which means fractions. So we're going to be dealing with fractions and we're going to be factoring. So I recommend that you watch this video as many times as you need to be able to refresh your memory on factoring if that's something that you're not really feeling very confident with. And then I also recommend that you spend as much time as possible in practice doing as many problems as you can until you feel comfortable with it. The factoring problems are not really complicated in MA 128, but there is a lot of factoring. So just please keep that in mind. So hopefully this was helpful to you, and I will see you in the next video. Make sure you reach out if you have any questions. I'm happy to help.